Hello, I'm Reggie York. This is a presentation on using the paired t-test when you want to compare the matched scores of a group of people. At the end of this presentation, you will be able to employ the special Excel file that I have composed for calculating the paired t-test for comparing the matched scores of a group of people. You will know how to use this file to determine the value both of t and p, which will help you determine statistical significance. This means, of course, you have matched scores. You will know how to use this file to determine the effect size, which is an aid in determining practical significance. This means that you have scores for two variables for one group of people, and the scores are matched. An example would be pre-test and post-test scores for, say, 12 clients or whatever. You wish to know if these two sets of scores are different. You understand the value of p in statistics and what statistical significance means and things of that nature. Here's an example. You collected anxiety scores for 17 clients before and after treatment, and you computed a gain score for each client. You're able to match each client's pre-test scores with his or her post-test scores. So you have pre-test and post-test scores for each person on anxiety. So you have two variables, pre-test scores and post-test scores, and it's matched data. Here's an example. Person number 1 had a pre-test of 13 and a post-test of 11. Person number 2 had a pre-test score of 14, post-test score of 9. Person 3 went from 16 to 10. Person 4 went from 17 to 17, meaning they did not change. 5 went from 15 to 7. 6 went from 11 to 8. So these scores are all going down with the exception of the one that stayed the same. So what does the t-test do? The t-distribution is a little different from the normal distribution. It's used where the sample size is small and population standard deviation is unknown. Thus, it is very useful for human service evaluation. It tells where the mean scores are significantly different. In our case, or our example, it is the mean pre-test score and the mean post-test scores. Are these significantly different? Let's talk about statistical significance and practical significance. Statistical significance tells us how likely our data would occur by chance. Practical significance is a matter of opinion about the extent that our data is noteworthy, or the extent that the difference is noteworthy. It's difficult to have practical significance in the absence of statistical significance, given the basic meaning of failing to find statistical significance. If you fail to find statistical significance, you have not ruled out chance as the explanation for your data. So how could you declare that data to be meaningful in answering your research question? Effect size helps with practical significance. The effect size is a score that represents the differences in scores measured in regard to standard deviations. The greater the effect size, the greater is the difference. So the effect size represents number of standard deviations. The mean IQ score is 100 and the standard deviation is 15. So if your IQ is 115, you are one standard deviation above the average for IQ. Effect sizes of 0.3 are considered low, 0.5 is considered medium, and 0.8 is considered large. That's arbitrary, just some suggested guidelines from the experts. It's not particularly scientific, just an opinion. The effect size for the one sample t-test, the formula for calculating the effect size for the paired t-test is the difference between the mean for the pre-test scores and the mean of the post-test scores divided by the standard deviation of the pre-test scores. That's how it's calculated. You don't have to do that because the computer does it for you. This shows how many standard deviations of difference there are between the pre-test and post-test scores. It takes those numbers, which may be 14, 23, and 18, and converts it to a standard deviation. Is it one standard deviation? Is it a half a standard deviation, or whatever? And it gives you the advantage of being able to compare results of two different studies that used a different tool for measuring progress. Now you are ready to use the Excel file. You'll load the Excel software. You will load the file entitled One Sample T-Test. So let's do that right now. Here we have the file on the screen. I want you to stop. Maybe you can pause for just a moment to read this first part. Hit the pause button, read those instructions, and then come back to me. Okay, I assume you have done the reviewing of the information. What you have here are pretest scores, post-test scores, the gain, the difference, that is to say. Here you have the mean pretest, the mean post-test, the mean gain score. Of critical importance too, of course, are these three numbers. This is the value of P, that tells you statistical significance. This is the value of T, and this is the effect size. And you will see that you have excuse me. Let's go back up here and demonstrate. Let's throw in some numbers here. Let's say the first person in your data had a pretest of 12, post-test of 15, with a gain of 3. Now this means, of course, that we're measuring something where higher scores mean better. Let's call this self-esteem. Higher scores are better self-esteem. So if you go from 12 to 15 on self-esteem, you've gained 3 points. If your measurement tool does it the opposite, then you have to compute your gain score differently, of course. If, for example, I had just entered scores for depression, and higher scores means more depression, 12 for pretest, 15 for post-test, that would mean depression had gone up. So I would have calculated the gain score here to be a -3, not 3. Okay? But let's stay with the self-esteem, meaning higher scores are better. And let's put a 10 right there. Let's put a 12 right there. And let's put a 2 right there. How about this one? 14 and 14, 0, meaning it didn't change. The next person, 18, 15, and now we have -3 because this person went down on self-esteem. So they got a negative score for gain. 11, 17, 6, 10, 15, whoops, I'm sorry, I just messed this up. 10. Okay, let's try again. 10, then 15. This means this one is 5. Okay, those are the data. Here we see the mean pretest score was 12.5. The mean post-test was 14.6, meaning it did go up. Here are some other scores. Here's the mean gain score right there. That's the 2.16. Now let's look at statistical significance here. This is the value of P, 0.084. Now that does not reach the normal standard for social science data of 0.05 for declaring data to be statistically significant. If your standard is 0.10, however, then it would meet that particular standard. This is the value of T. Here we have the effect size. That means the difference can be represented by 0.77 of a standard deviation, about 3/4 of a standard deviation. Don't pay attention to the negative sign. You know what you're doing there. So you wouldn't report this as negative 0.77. You just report it as 0.77. Okay, this particular thing says the p-value is for the one-tailed t-test, which means you have a directional hypothesis that you would normally have if you're doing evaluation research. You have a directional hypothesis because you would hypothesize that in the example we just talked about with self-esteem, your hypothesis would be post-test scores will be higher than pre-test scores. That's what you have reason to believe will be the case here. In this situation, you would use the one-tailed t-test for determining the p-value, rather than the two-tailed t-test. The latter is more conservative and is usually employed as the default whenever you use a statistical software such as SPSS and so forth. Okay, I hope now you know how to use this particular statistic with this particular file.